Power. It's all around us, goes with us, takes us further. Every connection, every invention, every device that makes life better begins here. Power unlocks progress, but also can hold it back. The limits of power are the limits of innovation. That's why we work every day to push these limits, to push more power in smaller spaces, to extend battery life by lowering standby power, to reduce EMI signatures, shortening time to EMI compliance, to help make systems even safer no matter the voltage, to reduce noise and achieve higher precision. We want to make more innovation possible for engineers everywhere. We've made power design simpler, invented breakthrough process and packaging technologies to take on power challenges like never before. We're working alongside engineering teams in every application area, solving problems together so they can design a better future. Texas Instruments, pushing power further.
They begin as thin slices of pure silicon. Over time, these silicon wafers have increased in size from just over an inch to the state-of-the-art 300mm wafers produced today. In fact, our fab was the world's first 300mm analog wafer fab. These larger wafers allow TI to build as many as 50,000 chips on a single wafer. This gives TI the capacity to produce billions of integrated circuits each year. A quarter of our fab's 1.1 million square feet is a dedicated cleanroom space, making it one of the largest cleanrooms in the world. On your tour, you're likely to see our fab team members wearing special clothing that ensures body oils, skin flakes, and lost hairs don't contaminate the massive clean space. Even the airflow in the facility is designed to virtually eliminate all particles in the air. With all the amazing things you'll see here at our fab, what you won't see is people carrying around heavy containers of silicon wafers. 99% of the wafer movement in this facility is automated, with computer-controlled pods on overhead tracks, making as many as 19,000 pickups and deliveries a day. These pods also protect the wafers by creating a mini environment that is even cleaner than the rest of the fab. It's all part of the intricate process of manufacturing unbelievably tiny technology that packs a powerful punch. Now that you've seen the wafers manufactured, the next and final stage of the process begins. Wafers are shipped to TI's test sites around the world. They are then encased in plastic packages that protect the chip inside and provide electrical connection points so that they can be easily integrated into the intended device. Texas Instruments offers state-of-the-art packaging technologies, from extremely simple to incredibly complex. The first step of the assembly test process is called backgrind, which is a process that ensures the finished chips are as thin as possible. Next, each wafer is cut into individual dies or chips. In the die attach process, each chip is placed on a substrate or metal frame, which will be included in the final package. During wire bonding, a material such as copper is used to bond the electrical interconnections between a semiconductor and its packaging. The mold process is where the chip and interconnects are inserted into the familiar epoxy plastic package that protects the chip inside. Next, during symbolization trim and form, packages are imprinted with TI's logo and other identifying information and trimmed to their final size. The packaged chips then undergo a final electrical test to ensure that they are performing to their intended specifications.
Jorge Carlos de la Serna Delgado, and my project is about measurement system analysis for quality improvement. Study at Texas Instrument Company. Below is a brief explanation of the topics. Let's talk about what is Texas Instrument in Aguascalientes, Mexico. The introduction The introduction is Texas Instrument Aguascalientes plant has the objective of conduction a capacity study of its measurement system that is applied to the electrical test of the TO92 voltage regulator chip. This study focused on the validation of the capacity of the measurement system in the electrical test in two main aspects: the temperature and the voltage that are applied to the electrical test for the sample of 5 chips from the same production plot. Measurement: accurate individual measurements and the average of these are very close to the true value. Respectable, very similar repeated measurement made by a person on the same measurement. Reproducibly, two or more people measuring the same objective obtain very similar results on average. Stable over time. The measurement system does not change over time. The source of variability that can be evaluated in the repeatability and reproducibility study are variability of the product of the instrument and the operator. The error of variability of measurements due to the repartivity and reproducibility in obtained with, and there are some examples of the variability of the company. Measurement system compatibility. Texas Instrument have part number manufacturer that is Texas Instruments, thermal resistance, Gage R&R study crossed. The measurement system consists of two quality inspectors who use the same measurement instrument and collect the measurement of temperature and output voltage. For the electrical test of the chip, the data is on the scale of degrees centigrade and millivolts. In the study, it is relevant to test the following hypothesis. H1, the difference between the measurement is not significant. The measurements are similar. H2, the difference between the measurement made by one inspector and the measurement made by the other inspector is not significant. The inspectors measure in the same way. H3, the difference between the measurement of the inspector part combination is not significant. There is not inspector part combination that is very different. That is, there are not interactions. J.R. study ANOVA method. Two-way ANOVA table with interaction. Source part inspector, repartibility total. The first hypothesis is rejected and hypotheses 2 and 3 are not rejected. There is another example of tables of chart by inspector, components of variation, arrows by part, arrows by inspector, and X bar chart by inspector. Thanks for the attention.